Hopefully you've already seen our video describing precision, recall, and accuracy. But as a quick review, we can take a look at those three basic metrics. Accuracy is about guessing right as frequently as possible. We don't really care about false positives or false negatives as long as we're maximizing the number of correct guesses. For other use cases, we might care about precision, where we want to make sure that every time we guess X, it actually is X. Finally, we also might want to make sure that we capture the maximum number of X outcomes, even if we might get some wrong compared to the precision or accuracy cases. For precision, we're trying to minimize false positives, and recall, we're trying to minimize false negatives. But F1 score takes a different approach and tries to balance between precision and recall. We neither want to always guess that the outcome is going to happen, nor do we want to say we're going to be very conservative and only take one shot on goal and try and just get that one correctly. So in many use cases, when we're not explicitly maximizing for either precision or recall, F1 manages to be a nice blend. Mathematically, it's the harmonic mean of the two. And so what we might get is 2 times the precision times the recall over the precision plus the recall. Taking a look at the formula, what we actually can notice is that when precision or recall are close to 0, F1 score becomes close to 0 in a way that's nonlinear to the decrease of each of those values. Comparing it to accuracy, which is just the overall statement of correctness, we can see that F1 score actually penalizes very low precision or very low recall much more harshly. Take an event that happens 0.1% of the time. If we naively try and maximize accuracy, we might build a model that says this event never happens. That model will actually be correct 99.9% of the time, but that's completely useless because it never actually detects the event we care about. When we use F1 score rather than accuracy though, we see that recall is 0 for that use case because we recall 0% of the events when they happen. And that leads F1 score to also end up at 0. When there are more than 2 cases, we might have to use macro or micro F1. When there's 2 classes, it's relatively simple. If it's not one, it's going to be the other. When we have a multi-class prediction and want to represent it as a single score, what we might use is macro or micro F1. For each individual outcome, high, medium, low, we might have a precision score for high, a recall score for high, and an F1 score for predicting high. We have a precision or recall F1 for medium, and then again for low. For macro F1, macro precision and macro recall, we just straight average all 3 individual classes F1 scores. For micro F1, we actually want to total up the true and false positive counts overall and then do the division later. This is more of an equivalent of weighted average, whereas the first one treats all classes as equal. So imagine that we have an F1 score of 0.7 for predicting X correctly, and X has 10,000 observations. And then we have F1 score of 0.1 for 2 other outcomes, Y and Z, with many fewer outcomes. In this case, we would say macro F1 is 0.3. Even though there's many fewer observations of Y and Z, we treat them as equal to X, and we just average the F1 score straight down the line. In the second case, we actually want to treat being correct, true positive, true negative, false negative, as weighted by the frequency of observations. And we treat being correct across all the classes equally. So being correct about X is worth just as much as being correct about Z. And in that particular outcome, we would say micro F1 is probably very close to 0.7 because 98% of all observations are actually for class X, which has the F1 score of 0.7. When classes are very imbalanced, there are some that are much more frequent than others, but we still care about those minority or infrequent classes. Getting those infrequent classes wrong is penalized much more harshly in macro F1 than micro F1. So once again, to take those examples from earlier, there are definitely situations where we want to maximize on precision and recall. Nuclear missile launch detection, the most precise outcome is best. For pedestrian detection, the most high value of recall is desired. But maybe for something like supply chain delays, we actually want to balance between precision and recall. Most of the parts are not delayed, so accuracy is a bad measure. If we're trying to predict whether a part is going to show up late to the factory or not, an accurate model might always just guess no and be right 99.9% of the time. Instead, what we want to balance between is being too alarmist or too complacent, which is what precision and recall might give us. And so in this particular supply chain delay example, we would use F1 score. Jumping over to the same example that we used for the precision, recall, and accuracy use case, we have a key variable of cancellation of membership for customer churn and some other factors about the customer in the store. We left off on producing a model for accuracy, recall, and precision. We can see that the F1 score in the case of accuracy was 0.51 for true. When we took a look at the one that maximizes recall, we see that the F1 score is actually slightly lower, down to 0.5. And we go down to F1 score for the one that maximizes precision, and we see that it actually has gone down even further to 0.265. Because in that case, we maximized precision so much that we gave up a lot of the recall, and we ended up hurting F1 score by a lot as a result. Because once again, when we take the harmonic mean or multiply these two numbers together, the smallness of recall hurts the overall score much more. So let's rerun this model one last time with F1 score as our maximizing factor and see what we get out as a result. In this case, we have another pipeline where we've balanced between precision and recall. So just to compare against the accuracy box, we can see that compared to the accuracy maximizing result, we actually have found a result that is much higher in recall than the accuracy example, slightly lower on precision than the accuracy example, and something that is much more in line with balancing precision and recall and trying to keep the two close together to keep the F1 score higher at 0.56 than any of the other examples we looked at.